For today, we have a very important topic, and that is called uh, calculating components of a vector. Now, this is the situation, children. I think before going to the situation, let me read from here. Children, look at this diagram of helicopter, and from here, listen carefully, children, and observe this diagram. In this diagram, in this image, actually, what you find here, see the how this helicopter, you can see here, helicopter is tilted. It's not completely, in a horizontal position. Helicopter is tilted. When it is tilted with a small angle, then why do we need to tilt a helicopter? That is one important thing. And when the pilot do in this way, so what happens then? See, we have this vector, that is one vector. This vector is the vector that the helicopter is tilted, and the helicopter is tilted with some angle theta with the horizontal, I can consider. Now I have this vector here, a vector, and I want to resolve this vector, resolve, R-E-S-O-L-V, resolve this vector into two rectangular components. These two rectangular components means one along the x-axis and the another component of this vector A into y direction. So then you can see one component of this vector A is along the vertical direction, along the y-axis. That is called the vertical component. And what are the importance and significance of this vertical components? It balanced the weight. How to draw the weight? The weight is m into g, that is acting vertically downward. So as per the Newton's third law, children, for every action there is a reaction. So vertical component is balanced by, means weight is balanced by the vertical component of this vector A. Now we have another component, and what is the another component? That is called the horizontal component. Horizontal component. And what is the importance of the horizontal component? Horizontal component make possible that the helicopter or the airplane, it can move in the forward directions. Helicopter can move in the forward direction due to the horizontal component. And the weight or the helicopter is balanced by the vertical component. And this A vector, it states that the helicopter is also moving upward. Helicopter is moving upward or maybe and going in the forward directions. Both cases are possible here. So let us look, children, let's discuss more in detail how to resolve a vector, a single vector, into its two rectangular components. What do you mean by this statement? Let me share another screen, children. Now come here. Now, children, this is the situation. This is not like a parallelogram. In parallelogram, we have seen we need two vectors to find the resultant. But here the situation is different. We have only one vector. We have only this single vector, children. And suppose this is our force. When some kind of force is acting on any object which is here at this point. Now I want to complete a rectangle by taking x axis. This is our x axis, children. And then I want to draw another axis, that is our y axis. Y axis, it is perpendicular to the x axis. And now assume, children, that this F, a force acting on any object, this force is acting on object with an angle theta with the x direction. Listen carefully, children. This theta is an angle made by the force with the horizontal direction. So this angle theta can be along the x-axis and it can be along the y-axis, and we will try to see both the cases one by one. Now here, this theta is the angle made by the force, made by the velocity vector with the x-axis. Now, further children, in this case, I want to write that fx here. What is this fx? Fx represent the component of force. Let me write here. Component of force. One of the component of force along x direction or x-axis. I will to take another component of force along the y direction, and suppose another component of force is Fy. What is this Fy? Let me write. This Fy is again the component of force but along y direction. And what are these components? We will discuss. We are going to discuss now on it. And we need to calculate what is this value of Fx and what is this value of Fy. Now we will complete a rectangular or parallelogram. Just do a construction part here. Wherever you find the tip of the arrows and join, and suppose we have this a rectangle. So here in this question, children, we have resolved a vector f into two rectangular components. One of the component of force is Fx, which is acting along the x direction, and one of the component of force is along y direction, that is Fy, which is acting along the y direction. So what is the value of this Fx? What is the value of this Fy? And how would you calculate? For that, you need to apply a trigonometry, children. And you are grade 9, and I don't think if you have not studied in mathematics trigonometry. So just I'm going to give you a just brief information about the trigonometry. Here, if I try to find out cos theta, okay, let me write here triangle A, B, and C. Take this triangle ABC. In triangle ABC, find the value of cos theta. And I don't know whether you are aware about this. How much is cos theta? Anyone in grade 9? Cos theta is equal to
adjacent over hypotenuse, which is Fx over F.
Kezia, please repeat what you were talking.
Gayatri and I were just saying that cos theta will be equal to adjacent over hypotenuse, which in this case will be Fx over F.
Okay, so cos theta, yeah, children, thank you, Kezia. This cos theta is equal to, I will take the x direction, that is called the base of the triangle, or that is called the run also, base divided by the hypotenuse. What is the hypotenuse here? That the pink line here you can see. And and along the pink line, I have taken that is F vector. So I will take here F. What is base? On the base, we have Fx. I have written this value Fx divided by F, and we can calculate here the value of Fx. So this Fx is equal to F cos theta. So we have this value Fx is equal to F cos theta. So instead of Fx, you can write here along the x-axis F cos theta, children. So if suppose at point A, if we have any object, so the object will move along the horizontal direction, not due to this force F, but one of the component of force which is acting along the x direction, and that component is F cos theta. In exams, you have to put the value of this F. What is the value of the? It may be 30, it may be 40, it may be 90. So that numerical value you have to put cos theta, children. Theta, you have to put this value theta. This theta, it can be 0 degree, it can be 20 degree, it can be 15 degree, it can be any angle, children. It can be of any angle. So whatever the angle is given in exam, you have to put that value of angle to calculate the Fx. What is this Fx, children? Again, Read it carefully. Component of force along x direction. So in your exams, there will be some questions in which examiner will ask that find the x component of a given vector, or maybe find the y component of a given vector. Similarly, children, to calculate the y component, again, you have to take the same triangle. You have to take the same triangle, but find out sine theta. Find out sine theta. So sine theta is given by, what is the equation for sine theta, Kezia?
Sine
Opposite
theta.
over hypotenuse.
Opposite over hypotenuse.
Yeah, opposite over hypotenuse. Opposite will be Fy. Hypotenuse still the same.
Okay, I will write here rise over hypotenuse. So for hypotenuse, I will write h only. And the rise means that the y-axis, this side, how much is this? This is the y. They are talking about the y, Fy, this value. Because they are equal, I will write here Fy divided by, again, the hypotenuse h is given by f, cross multiply, and you will get Fy is equal to f sine theta. F cos theta and f sine theta. These are the two components, and this is the way how to resolve. We have resolved f vector into two rectangular components. One component is along the x direction, and the another component of force is along the y direction. What are their values? Remember, f cos theta along x axis, f sine theta along y axis. Now, children, one more thing here in this topic, I want to tell you that the easiest way, whenever you find, suppose this vector is given, now it is A, this A is given, or vector A is given, and you have to resolve, and suppose now this angle is theta 30 degree. You have to resolve. So it means, how will you resolve this? You can write here, this will be A cos 30 degree along the x direction, and A sine theta, theta is how much? 30 degree along the y direction. So this is the way to write or to resolve a vector into two rectangular components. Cos will come, children, remember, cos will come with the angle. Whatever the direction, in what direction angle is given, so the x component will, means cos will go in the direction of theta. For example, children, suppose you have a situation, even this is a mathematical concept, theta is here. Theta is given along the y-axis. And you again suppose C vector. How will you resolve it? So whether you will write this C cos theta here, is this correct? If you write C cos theta here, children, then it will be wrong. Along the direction of theta, your component of cos will be here. C cos theta will be along this side, and but here this will be C sine theta. Even you can also check it by completing the triangle, and again by using the trigonometric equation cos theta sine theta. You can do it again. You can check it. So please remember, I'm not going to tell you, but if some students will struggle in this, then you later can message me. So this is the way, children, how to resolve a vector. I want to move to the next topic. Question number 3. On question number 3, on the right, someone is pushing a lawn mower. By scale, find the vertical and the horizontal component of the 100 Newton force. You need to calculate, children. You need to calculate vertical and the horizontal component of what? Of 100 Newton force. But now, children, here, look at this picture. And in this picture, the lawn mower, this person pushing the lawn mower with a force of 100 Newton, and see the direction of this force. Here, as he's pushing, so this vector is acting with an angle of 30 degree with the horizontal. So remember this diagram. I'm going to the next page, children, and to solve this question here. And so suppose this is our horizontal surface on which the lone roller is moving. So I'm not taking that exact same figure, children. Let me take, this is our roller. And on this object that the person has applied a force of 100 Newton in this way, and what is the theta here? So theta, if I take this, suppose this is like a x-axis, so theta something here is 30 degree given in the statement. How will you find out this? I'd find the vertical component and find the horizontal component of 100 Newton force. How will you do, children? Take a moment, children, and think about. We have this situation that a person is applying a force of 100 Newton, and then he has applied a force with an angle of theta, and that theta is equal to 30 degree. And this is the surface, children, here. This is the surface ground. Now, how to resolve this force 100 Newton along the x-axis and along the y-axis? If some of you are saying, sir, it is very simple that just draw x-axis and y-axis and take along this side, this will be 100 cos 30, and this side it will be 100 sine 30. If some of you are looking in this way, so then your answer will be wrong. Look at the direction of this arrow. Look at the direction of this arrow. If you say this cos 100 cos 30, that this object will move along this direction, and this is not possible as the roller is moving along this side. It's not moving along this side. The effect of this force 100 Newton, this roller is moving to the negative x-axis, you will say. So if this arrow is upward direction, so definitely that this part will be correct. But here they have mentioned that 100 Newton is acting in the downward direction. So just let me give it. Instead of doing this question will be done. You need to do a construction part. Produce this 100 Newton in the third quadrant. You know, third quadrant. First quadrant is here, second quadrant is here, third quadrant is here, and the fourth quadrant is here. Entire trigonometry is I'm using here. So in third quadrant, and again another mathematics, you know, theta, this theta is 30 degree. So this angle is also equal to 30 degree. Vertically opposite angles are equal. Can I do in this way, Lee? Can I write this angle is also equal to 30 degree? Use mathematics.
Yes, sir.
These are the vertically opposite angles, 30 degree. And this now arrow, this is my 100 Newton force, which is acting downward. I can do in this way. Now it is very simple. Now resolve it. So along the x direction, this will be 100. I said you children, along the direction of theta, you have to take cos. 100 cos 30 will be along this side, where you have to need to draw y-axis, children. To take the y-axis, children, this will be here, and the second component of this 100 Newton force will be 100 sine 30 degree. That is the answer, and even you can put the value one by one. So fx will be 100 cos 30. May I know what is the value of cos 30, children? Look into your calculator, children.
√3/2, which will be
So that finally this is 50 √3. You can put the value of √3, and whatever the answer, that will be in Newton. Okay. And similarly for finding the y component, fy is equal to 100 sine 30. I know 1/2. So this is equal to 50 Newton.
Sir, the answer is 7.71.
Please do now. Please multiply. Root 3, 50 root 3. That is 7.7.
71257.
Sorry. Please repeat.
7.7125.
Excellent. If the calculation is correct, children, then you can find this is the answer.
Wait, sir, it's 7.71, not
Okay,
1.71.
so 7.1, 7.1 something. Okay, Newton. So later on, children, we will practice some more questions to understand how to resolve this component of force into two rectangular components. Now I want to move to the next topic, and our next topic is circular motion.